Yeah, welcome to Point to Point channel. So, as part of Java 8 series, today I will discuss about streams concept. Yeah. So, basically, what is a stream? Okay. So, let's assume you have some source. So, source could be a collection or array or any input output channel. Okay. Now, if you want to process the elements or objects, whatever are stored within that source, okay. So, then you need to take the help of a stream. So basically you can imagine stream as a sequence of elements, okay, sequence of elements which are coming out of that particular source. Okay, so you know so basically these streams are used to process the elements. So what is meant by processing? So for example, if you want to perform some filtering operation, or if you want to find some unique elements, or if you want to sort the elements, or you want to map the elements from one type to another type. So like this, you may have n number of requirements as part of your day-to-day life, right? So in order to fulfill all your requirements, like we need to take the help of streams, right? So yeah, so you can imagine the streams, so something like this, as per this diagram. Okay, so see, elements are just flowing one by one in a sequential way. So something like this. So this is a stream. Okay, and after that, what are the stream features? Okay, so as I said, okay, streams represent the sequence of elements or objects of a specific type. Okay, that could be of a some generic type. Okay, stream of integers, a stream of strings, a stream of employees, or something like that. Okay, then after that, so we should not get confused between a collection and a stream. So basically a collection is used to store a data. It acts as a kind of a data structure, but you cannot store the data within the stream. So that's the important point. So and after that, so so streams are meant for processing the elements or objects which are stored in that collection, right? So it doesn't mean streams are going to manipulate the elements or objects. I mean, it end of the day your collection is intact. I mean, so streams are not going to change any data within that collection. So this is one more point. Okay, so yeah, so don't get confused with the streams which are available in java.io.streams, which we used to learn since from the JDK 1 version onwards. So those streams are meant for reading and writing operations for bytes and characters or something like that. So so these streams are introduced in the Java 8, that too in a java.util.stream package. Okay. So basically, stream is an interface. Okay. So this is in the java.util .stream package. Okay. So so there are multiple ways to create a stream. Anyhow, I will show the demo shortly. So no, but the main key methodology is the collection interface has the two important default methods, that is stream method and parallel stream method. So since list set all important interfaces are already extending the collection interface, so by that way we can happily invoke a default methods of collection interface, that is stream or parallel stream, something like that. Okay, so this is what just some time before I already discussed. So basically, the second point is, but if you want to process the objects from the collection in declarative style, so similar to SQL statements, then you should go for the streams. So declarative style in the sense you will simply give the instructions, so you no need to bother how it is, executing those instructions internally. So yeah, so stream representation in the sense, as I said, you will have some source. Okay, so from that source you will start processing those elements, right? So as part of that processing, you will have two types of operations. One is intermediate operation and the second one is terminal operation. So here you may have zero or n number of intermediate operations, but you will always have a single terminal operation. Okay, so So, you may have source and you may invoke straight away terminal operation also. Okay, why? Because in this case, there are zero intermediate operations. That could be possible, right, as per this diagram. So yeah, so as I said just some time before, we do have, two types of operations, intermediate and terminal. So intermediate in the sense, we can perform filtering, mapping, flat map, distinct, sorted, peak method, limit, skip. So there are a number of intermediate operations. So all these intermediate operations simply return a one more stream. So this is very important. So on terminal operations, you know, you have performed n number of intermediate operations. You have accumulated some results. Now you want to get those results. So then you need to use the terminal operation. So these are all terminal operations. So collect, count, reduce, for each, min, max, any match. So many terminal operations are there, right? Yeah. uh, Yeah, so one more important point is stream intermediate operations, are kind of a lazy operation. So, they don't get executed until a terminal operation is invoked. This is very important. So, for example, if you write, so four intermediate operations, okay, that's it. So, and if you try to execute your program, nothing will happen. Why? Because you should add a connecting terminal operation. So then only the all intermediate operations gets executed, followed by your terminal operation. So this is important point. Okay. um, yeah, so terminal operations will not return a stream, as I said. So terminal operations return a some concrete result, or you may have some list or set or map or whatever. Why? Because finally you are getting a result from all the intermediate operations, uh, outcome. Yeah, so we do have primitive streams, int stream, long stream, double stream. So these streams are specific to some primitive values. Okay. So yeah, so now without wasting time, let's jump into the coding part. Yeah, so here if you see, we can create streams in a number of ways. So I want to show you a few ways here. Okay. So the first methodology here, if you see, okay, you know, um, so this off method is a very famous method, right? Well, I think you may have already seen in optional.off is there, and in the list interface also list.off. You can create a list of elements in a similar way. Stream.off. Okay, it's a kind of a static method. Okay, so before that, I just want to show you the API. So one second. See, this is a stream API. So, I mean, it is recommended to go through this API. Here, if you see clearly, interface stream API. Okay, and it extends a, um, so here you see it extends a base stream. Okay. Um, so here, if you see, if you come down, okay. So here, if you see static methods are there, right? So here, if you see builder method is there, iterate method, empty method, generate method, okay, off method. So these are all static methods. So we can create a stream using these static methods. So now, okay, here if you see, so this is the first approach. Okay, so what I'm doing, so stream.off, I just took some 5 integers. Now, I'm not performing any intermediate operation. Straight away, I'm invoking some terminal operation. That is, for each method, I just want to iterate all those elements. Okay, so this is approach one. Okay, similarly, approach two, here if you see, so I have some array, okay, with some strings. Okay, now, how to create a stream, by treating your array as a some source. Okay, so now here if you see arrays dot stream of, just you need to pass that array reference here. So here also there is no intermediate operation, I'm just invoking terminal operation. Okay, so what is approach number three? So approach number three here is, this time I want to create some empty stream. Empty stream in the sense, it's a stream which does not have any elements or objects. So just you need to invoke stream.empty. Okay, I'm just printing the elements. Obviously, it will not print anything. Why? Because it is empty stream. So there is one more way to create empty stream is stream.off. Don't pass anything. So that also creates empty stream. Okay, and after that, so there is one more approach. Okay, so here in this approach, yeah, so I want to create a stream using a builder method. Okay, so here if you see stream dot builder method, okay, then you can add all your elements slowly with the help of add method, dot add of element 1, dot add of element 2, or something like that. So once you are done, then simply invoke a build method. So then it will simply create a stream. So then you want to you can perform either intermediate operation or terminal operation. Okay. So yes, so there is one more approach, iterate method. So basically this iterate method is used to create a infinite stream in the sense infinite elements of a stream. So here if you see iterate method, so basically it will have two parameters. So the first parameter is some some value, okay, and the second parameter is kind of a accumulator. Here I am just summing, consolidating all the numbers. I mean, let's assume starting from 0, so it will keep on printing 0 100 or something like that. So I'm just restricting to first 10 numbers. So just why I just used one intermediate operation, in this case dot limit, then followed by terminal operation, that is for each. Okay. And similarly there is one more method, generate method. So basically generate method expects a supplier interface. So here so supplier interface, I'm just passing some UID colon random UID. So then again I am making use of intermediate operation limit method, and finally printing for each method. So these are various ways of creating a stream stream instance. Okay, so so let me run this. Okay, so I just want to show the output. Yeah, so here if you see, this is the first approach. Okay, in the first approach stream.off, I'm just printing all the elements. So second approach, here if you see Java stream API, so here if you see the second approach, I have three strings, right? So Java stream API, it has printed. Okay, so and after that is approach 3, stream.empty. As I said, we don't have any elements, obviously there is no output. Now go to approach 4. Okay, here if you see, I just create a stream using a builder method with the two strings, stream and API. So here if you see, stream and API got printed. Okay, and after that approach 5, okay, here if you see, okay, it just printed some 10 numbers from 0 to 9. Okay, and after that approach 6 using a generate method. Okay, it just printed only two UUID numbers. Okay, here if you see two UUID numbers. So I hope you are clear, in creating various ways of streams. Okay, so now now I want to show you the most famous way of creating a stream in a real time. Okay, so just to save some time, okay, I just want to copy the code. Okay, just sometime before I have worked out all various scenarios. Okay, so here let me copy this piece. uh, yeah, so here if you see, yeah, so I just created some list of integers. Here if you see a list of integers, now list.stream. So just sometime before I have shown you, right, collection interface has two default methods, a stream method and parallel stream method. Okay, let me show you here. Okay, so I guess this is collection interface. Okay, no, um, yeah, see, so this is collector. Okay, one second. Collectors, yeah, yeah. So here if you see, this is collection interface. In this collection interface, if you see the default methods, So here if you see stream method, okay, and parallel stream method, okay, so these two are the default methods. No, so a list set all other interfaces are already extending collection interface. So by that way you can have access to invoke this stream or parallel stream method. So by that way here if you see I have some list. Okay, now happily I can invoke this stream method. So this is which is a default method in the collection interface. No, so as soon as I invoke list.stream, I will get some stream. It will simply return a stream, right? So by that way, I have a stream in my hand right now. Once you have a stream, so I'm just printing this stream also, what it will print or something like that. Okay. So then stream one dot. Now I am trying to perform some filtering operation. So in the filter, so so one point I want to highlight here. So basically streams are meant for processing elements or objects which are stored in your source, right, or collection or array or whatever. So now as part of this processing you will make use of um, n number of predefined functional interfaces in the form of lambda expressions or method references. So what I'm trying to say here is, in other words, so for example, if you want to perform filter operation, so obviously filter operation expects a predicate, and if you want to perform a map operation, okay, then map operation expects a function. Okay, so you know if you want to perform a sorting operation, sorted operation method expects a comparator. So like this, most of your stream key operations are expecting a functional interfaces. No, you need to pass a implementation to those functional interfaces. So just a note this point. I mean, this is an important point. Okay. So now here if you see I'm just performing a filter operation. So intentionally I have written multiple lines within the implementation. So just to print something here. So here if you see I'm just printing each filter element, and after that um, so this filter method is the intermediate operation which returns one more stream 2. Okay, now I'm invoking one more intermediate operation with the help of this stream 2. Now stream 2 dot map, again internally I'm just once again printing some SOP what's happening. I mean, just to know what and all elements are are part of this operation. Okay, and after that so finally if you see stream 3 dot for each, I'm just printing all the outcome of the elements. Okay, so now let's see what it prints. So here if you see we have some integers 1 2 4 6, some integers are there, right? So basically what I am doing, okay, here initially I am performing some filter operation. So basically filter operation is to find out the even numbers, okay, and followed by map. So in the map here I'm just adding 2 to each integer. Okay, and finally I'm just printing. That's it, one filter operation and one map operation, that's it. Okay, so here if you see the output, okay, so here okay, so one point here I want to highlight. Okay, so probably everyone is under kind of assumption. For example, if I'm performing filter operation in the sense, okay, so basically immediately it will filter all these integers with even numbers. Okay, and immediately it will it will find out all the even numbers, and it will so that all list of even numbers are passed to the next intermediate operation, that is map method. So something like that, we used to think in that way, right? But in reality streams operates in a kind of a vertical way of processing in the sense, you know so for example, if you see the output, okay, so what happened, filter element 1, okay, first it has filtered, it has taken the first element. Okay, this is a odd number. Okay, next filter element 2. So that means second element, it has taken the second element. Okay, second, this time this is a even number. So since it is a even number, okay, so this condition is true, right? So this is a condition is true. So then that particular even number immediately it will pass to the second intermediate operation, that is map method. So by that way, here if you see your map method, I'm just adding number 2. Now 2 plus 2 4. Here it has just written 4. So something like that. So now here if you see immediately 4 and 6 already straight away these are even numbers, right? So then again it has passed that 4 to the next intermediate operation. Here if you see, okay, so here I'm just highlighting here if you see 4 and again the second intermediate operation also 4 and again 4 plus 2 6. Similarly 6, 6 and 8. Okay, and after that if you see number 3. So number 3 and 8 are there. Obviously, filter element, here if you see 3, obviously it is a odd number. So this will not pass further to the next intermediate operation. And again it will pick one more iteration, this time 8. Okay, so sorry, here if you see this time 8 and 8 will be passed, since 8 is a even number, it will be passed to the next intermediate operation map, and by that way 8 and 10. So I hope it is clear. I mean to say, streams are processing intermediate operations in a kind of a vertical way. So first the condition is fulfilled, then that particular outcome is passed to the next intermediate operation. So then third intermediate operation, fourth intermediate operation, something like that. So this is this is also one more important point. Okay, and so there are few scenarios in which streams uh, streams will perform the intermediate operation all the elements. Okay, and it will simply pass all that outcome to the next intermediate operation. We do have such type of scenarios. Okay, let me show that scenario. Yeah, so here if you see, so this time what I'm doing, okay, um, so the same list I have taken. Okay, so this time what I'm doing here, obviously if you perform n number of intermediate operation, and your end of the day your list is intact. Okay, your list will not change or manipulate in any way. Okay, so here I'm just performing that one map operation. Okay, and followed by one sorting operation. Sorted, here I'm just passing some comparator. Okay, so basically this is a natural sorting only. Okay, I can do comparator dot natural order, but in order to just show some what's happening, I'm in order to add SOP, I just added this type of logic. Okay, and after that uh, so one more map. So basically I have two maps, map 1 and map 2. In between map 1 and map 2 I just inserted some sorting operation. Finally I'm printing. Okay, so now let's see what it prints. So in yeah, yeah, so here if you see, here if you see, yeah, so let me highlight this output. Okay, so here if you see map element 1 2 3 4, so happily it has printed elements. So that means the first map operation has executed on all elements of your particular list. Then it simply passes that outcome to the next intermediate operation, that is sorting operation. So why? So in the previous case, the filtering operation, map operation, everything happened in a vertical way. That is for each integer. Okay. So, but in this case, it has got all the outcome at once and simply passed that outcome to the next sorting operation. Why? Because in order to perform the sorting, basically you need to have all the elements at a time, right? So it's not possible to pass a single integer to the sorting method and then again pass a second integer to the sorting method. It's not like that, right? So no, so overall, what I'm trying to say is, the streams basically, um, no, process the elements in a smart way. So based on the intermediate operation type, it will take the decision. It will take the call accordingly. Okay. So this is what. Okay. And after that, yeah. So let me copy this piece. Okay. So now okay, just to demonstrate in detail, okay, I just split it, each intermediate operation, in a separate way, and each intermediate operation has returned, fresh stream in our previous cases. Here, if you see, okay, stream dot sorted, it has returned stream or something like that. But in reality, we will simply, pipeline all the intermediate operation, terminal operations one by one. So, so here, that's what I have done here. If you see, okay, list dot stream, then I just invoked again map, then sorted again map. So that means, obviously map returns one more fresh stream. So now this sorted method is invoked on that return stream, and similarly sorted method returns one more stream. Then this map method returns on that return stream of sorted method. So something like that. Okay, so here if you see list dot stream, so basically it returns a sequential stream. Okay, so here if you see one more parallel stream, here if you see parallel stream. Okay, so parallel stream in the sense, okay, if your CPU is, a dual core or octa core processors, then um, so then parallel stream in the sense multiple streams are getting created, and all those streams are executed on separate cores of your CPU. So by that way, uh, you will get the outcome in a very less time. Okay, so then all your streams, finally consolidate all the outcomes of stream 1 and stream 2, and finally you will get the final output. Okay, so then the next question, when we need to go for sequences stream and when we need to go for the parallel stream. So basically, if you are very keen about the order of execution, then better to go with the sequential stream. Okay, if you are least bothered about the order of execution, then you can go with the parallel stream. Okay, so let me show the output here. The same output, whatever we have got earlier. Okay, the same output it will print. Okay, here if you see, so yeah, so sequential stream and parallel stream, okay, the same output, but of course, I mean, so the processing time varies. I mean, basically, if you have a very complicated calculations or something like that. Okay, so um, yeah, find first, yeah. So here just we are finding a first element of this particular thing. So here nothing, I mean, we are just mapping and then sorting. Okay, and then again mapping. So this time in the mapping I'm just adding number 2. Then finally I'm just trying to find out the first element of the outcome. That's it. Okay, so the next operation is, okay, yeah, so very important one, flat map. So flat map, so till now we have seen the map, right? So now what is flat map? So the difference between map and flat map is, let's assume if you are having a stream of elements, okay, as a the elements of your stream are itself has a one more list. So for example, here if you see stream dot off, okay, element 1 is again a list 1, okay, and element 2 is one more list. Okay, so if you have this type of stream, now if you do a mapping and if you print the elements, basically it will print a list 1 and list 2, list 3, or something like that. Now if you do a flat map, then it is going to be flatten the uh, flatten the list of your elements. Okay, so here if you see how to do a flat map, in the sense flat map collection this method reference of a stream or something like that. So then finally it will print something like that, 1 2 3 4 5 6. Okay, in case if you use a map instead of flat map, it will print list of 1 2 3 comma list of 4 5 6 or something like that. Okay, now let me show you the output. Yeah, so here if you see, it has printed 1 2 3 4 5 6. That is just because of flattening map. Okay, flat map. uh okay, so let me show you. uh, so in case if I do a map operation here, okay, so let's see what happens. Yeah, so here if you see, as I said, okay, it has printed a no uh, yeah, so it has printed reference pipeline, okay, stream 1 and a stream 2 or something like that. So why? Because you know um, so map of collection of stream, in the sense, so first element is a list 1 and list 2. So basically a reference pipeline is a class which implements a stream interface or something like that. So let me undo this. So if you have this type of requirements, better use a flat map. Okay. So and after that, if you want to find a unique elements, if you want to find a unique element, so basically, uh, yeah. So let's see here. If I have some list of, some stream of integers. Now, I want to find a unique elements. Basically, I want to eliminate the duplicate elements. So basically, here if you see, it will print only unique elements. Okay. Yeah, so here if you see, it has printed only unique elements. So basically, simply you need to invoke a distinct method, which is an intermediate operation. That's what I'm trying to say. Okay. And after that, peak method. So peak method is also intermediate operation. Basically, this peak method is used to, used to find all the elements, between each intermediate operation. Okay. Basically, this is used in the case of debugging. Okay. So let me show you. Okay, so I have some stream of integers. So here if you see, I'm performing some distinct operation, and after that some filtering operation. Okay, so here I just printed. So what's happening? I mean, so after finishing this distinct operation, what was the outcome? And similarly, what after finishing the filter method, what was the outcome? I just want to know. Okay, so here if you see, distinct element 1 and distinct element 2. Okay. Um, so as I said just some time before, basically streams operations performs in a vertical way of processing, right? Intermediate operation 1 for each element. That element is passed to the intermediate operation 2. So the same thing is happening here. Distinct element 1, 2, and then that 2 is passed to filtering element 2. Okay. Similarly, distinct element 4, then that is passed to filter element 4 or something like that. Okay. So yeah, this is for peak method. Okay, and let me copy these two intermediate operations at a time. So I just want to show limit and skip method. Okay, let me run this. So here if you see, let me explain this. So limit method, in the sense, okay, distinct method is basically it returns the all unique elements. Now I don't want all the outcome. I want to have a only first first three elements of the outcome. Then I need to use the limit method. Okay. So similarly, skip method, in the sense, I want to skip, the first three. So I want to have the remaining elements of the outcome. So in that case, we need to use the skip method. Basically, limit and skip both are intermediate operations. Here, if you see, this is the outcome. No. So and after that, you want to find the minimum, minimum element of your stream of integers. Okay. So how to do that? Yeah, so let me explain. So here is distinct method is there, and again min. So basically this this min is a terminal operation. Okay, so in the min method basically expects a comparator. Okay, so that's why I'm just passing integer colon comparator 2. Okay, so and then basically it returns a optional. So then I'm just making use of if present method. If it returns a value, then only I'm just printing that outcome. Okay, so there is a one more methodology to find the minimum element. Here if you see, I'm just scrolling down. Okay, once you have a unique elements, okay, there is one more method, intermediate operation, map to int. So basically it will return a int stream. So I already said, right, sometime before, we do have primitive streams, int stream, long stream, double stream. So if you invoke a map to int, basically it will return a int stream. In the int stream we have a straight away min method, so which will return the result of a minimum element. You no need to pass a comparator this time. So these are the two possible ways. Okay, here if you see, you have got the same output, 1 and 1. Okay. Yeah, and after that, now let's discuss about the key terminal operations. Okay, so here I want to show about the grouping by operation. Okay, so here if you see grouping by, so what is this grouping by? In the sense, here if you see, I have some list of employees. Okay, employee poso, I mean, so basic thing, name, age, salary. Okay, some department are there. Okay, so here if you see, there are no intermediate operation, emp list dot stream up to here clear, then dot collect. Okay, so this collect method is a terminal operation. So basically collect method expects a here if you see the API once. Okay, if you go to collect method. Okay, so collect method is expecting collector. So basically collector is an interface and collectors is an implementation class. Okay, so here if you see you know as I said, we need to pass the implementation class, right? Collectors. So within that collectors dot grouping by is there, right? So let me show you the API one so that you will feel comfortable. So here if you see, yeah, so here if you see, this is a interface collector. Okay, so and here if you see, this is a class collectors which implements that collector. Okay, so here if you see, you have a number of very important methods. Okay, grouping by, partitioning by, so many important methods are there. Okay, so here if you see, so when we need to use this grouping by, so let's assume you have some list of employees. Now um, you want to group your employees based on their department. So for example, um, uh, you want to know the count of employees in each department, QA department, dev department, or something like that. Then you need to take the help of this grouping by. So here if you see what I'm passing, in the first parameter I'm passing the department with the help of method reference, and the second parameter I'm just saying collectors dot counting method. Okay, so then you will get a the number of employees in each department. Okay, then finally I'm so basically it will return a map. So map in the sense, right, key value page. The key is a department and map value is a number of employees. Okay, so let me run this. So basically it will print something QA4 dev5 or something like that. Yeah, so here if you see, in QA department, two employees are there, development department, two employees are there, something like that. So this is the purpose of using grouping by. In real time we use a lot this particular grouping by. Okay, so similarly we have one more important terminal operation, that is partitioning by. Okay, so here if you see, yeah, so partitioning by, in the sense, there is a slight difference between a grouping by and partitioning by. Okay, grouping by, basically you are just grouping your employees based on some condition. Okay, so condition in the sense, I mean, you are just grouping the employees and you want to find some operations. I mean, you want to find some maximum salary in each department or minimum salary in each department, or the count of employees in each department or something like that. But if you want to if you want to divide all your employees into two groups, okay, group 1 and group 2, based on some predicate, based on some condition, then you need to take the help of partitioning by. So here what I am doing, my condition here is, I just want to divide all my employees who are earning more than 50,000. Okay, comes under one group. Okay, and less than 50,000 salary comes under one more group or something like that. Okay, so here let me print this. Yeah, so here if you see, basically it will return a boolean value, false and true. So here if you see, false in the sense, I mean, that condition will be false. Okay, that means earning less than 50,000. Okay, the true means earning greater than 50,000 or something like that. Okay, so now if you see, yeah, the next important terminal operation is summing int. So summing int in the sense, okay, yeah. So here also, what I am doing, there is no intermediate operation, dot collect. Okay. So this time collectors dot summing int of employee salary. So that means I am just consolidating all the salaries of all the employees. Okay. So basically here if you see, you have got the output. So this is the, you know, you know, final sum of all your employee salaries. Okay. So and after that joining operation. So this is also one more important key operation, terminal operation in your streams. Okay. So here if you see, yeah, let me run. So basically what I'm doing, I'm just printing all the employees names just separated by some comma. Okay. So here if you see collectors. Okay, so stream dot map. So map in the sense I'm just first getting all the employee names. Okay, with the help of method reference. Now finally dot collect. Okay, collectors dot joining. Okay, I'm just passing delimiter. Here you can see in the output. Okay, I've got all the employee names separated by a comma, something like that. Okay, so and after that, reduce method. So what is reduce method in the sense? Okay. So this is also one more important terminal operation. So reduce method in the sense, basically you have done some intermediate operation. Now you want to reduce that outcome into a some specific kind of result. So for example, you want to do some summing operation, sum operation, average operation, min operation, max operation. So that means obviously you will get a final single output, right? So that means you are reducing the outcome of all your previous intermediate operation into a some specific value with the help of some reduce method. Okay. So here if you see, I have taken the help of int stream dot range in the sense we can create int stream using the range method. Okay, so something 2 comma 5 I'm just passing. So here if you see reduce method, so in the reduce method what I'm doing, I'm taking two elements and I'm simply multiplying element 1 with element 2. Okay, then I'm just printing. So obviously it will print, right? I mean 2 into 3 into 4, so obviously 24 it will print. So let me run this. Yeah, so here if you see it has printed 24. Okay, so that's the purpose of reduce method. So in this example I just multiplied all the elements. You can do min you can find out min element, max element, or sum of elements or something like that. Okay, so this time so I want to show few more terminal operations. Okay, so yeah. Yeah, so let me run this. So we do have few terminal operations. So any match, all match, none match. So we have some. So here if you see, the first one is any match. So I have some stream of integers, three integers. So what I'm doing here, okay, any match. So just we need to pass some predicate. Predicate in the sense, right? I mean, obviously it will return either true or false. So here if you see. So I'm just passing, predicate implementation. Right? Everyone knows. I mean, predicate has some test method, right? So predicate is a function interface. So here, what I'm doing, I'm just finding the first character of each and every string. Okay, is a uppercase or not? That's what I'm trying to find. Okay, so in case if any single string also is having uppercase, then basically it will return a true. Why? Because this is any match. So here if you see the first string, that is one, here I have a o as a upper case, right? So similarly here if you see, so that's why it has printed true here. Okay, the next one is here if you see all match. So now in this time all strings 1 2 3, the first character is upper character, I mean uppercase, so that's why it has printed true. Now none match. So here if you see, all three strings are having first character as a lowercase, so that's why it has written true, none match. So this is what streams concept. Almost I have covered all key intermediate operations and terminal operations, and I have also shown the all possible ways of creating a stream. So the main important key point here is basically stream is meant for processing the elements or objects which are stored in your collection or array or any other source. So this is the main purpose of stream. So I hope this video is useful for you guys. I mean, if you really like my video, please like and share and subscribe to my channel. Thank you.